This video is on applied optimization. Modeling the situation that one wants to maximize or minimize is most likely what one will encounter in the business world. You need to learn how to create the model for each situation. There are some common steps that can help you. So the Extrema modeling process. Number one, translate the wording of the problem into a picture and a mathematical statement. This is usually the hardest part of the process. Number two, identify the objective function. This is what you want to maximize or minimize. If there are two more variables, find a constraint equation. This equation is what relates the variables to each other. And then part B is solve the constraint equation for one variable and substitute it into the objective equation. This gives you an equation of one variable. Then use calculus. Step 3 is to use calculus to find the extrema value. 4, determine if you did answer the question, then give answers as a sentence. A common situation in business to consider the revenue, cost, and profit in a situation. In many cases, you would want the following unknowns. The number of items, which you can call any letter such as Q for quantity, N for number, or you can even use X. Let's call that Q. P is the price that the items are sold. Really complicated situations can have prices change as the quantities change. For now, the price will be set, and we're going to call it P. The revenue function, R, is how much money is brought in from selling a number of items. It is always the price times the number sold. So R of Q is equal to P times Q. The cost function, C, is what it costs to make the items. This includes things like rent, employees, materials, electricity, research and development, and other type of quantities. This means that the cost function is not usually linear, and one needs to usually find it by using a statistical process called regression. The profit function is found by taking the revenue function minus the cost function. P of Q is equal to R of Q minus C of Q. So some mathematical concepts for business applications. There's a break-even point. This is the point where profit changes from negative to positive. The marginal cost, this is the cost to produce one more item. This would be C of Q plus 1 minus C of Q all over 1. This can be thought of as C of Q plus H minus C of Q all over Q plus H minus Q, or C of Q plus H minus C of Q all over H. Instead of H equal 1. Now, if one thought of it this way, then one could find the marginal cost by taking the derivative of the cost function. Marginal revenue from selling one more item. Similarly, marginal revenue is the derivative of the revenue function. Marginal profit from producing and selling one more item. Similarly, marginal profit is the derivative of the profit function. And then average cost has critical points where average cost and marginal costs are equal. So let's take an example. The following are the price-demand equation. Q is equal to 9,000 minus 3P. And the cost function C of Q is equal to 15,000 plus 150Q for the production of HD TVs, where Q is the number of HD TVs that can be sold at the price of $1 P per TV, and C of Q is the total cost in dollars of production of Q TVs. Find the price function and find the demand of this price function. So we know that Q is equal to 9,000 minus 3P. Solve this for P. So 3P is equal to 9,000 minus Q, dividing by 3. P is equal to 3,000 minus 1/3 Q. The domain is the fewest number of TVs you can make is 0. Since the lowest price you can sell a TV for is 0, the largest demand would be 9,000 TVs. So the domain is from 0 to 9,000. Find the marginal cost. The marginal cost is the derivative of the cost function. So the cost function is C of Q is equal to 15,000 plus 150Q, and the derivative of that would be 150. That's going to be dollars per TV. Find the revenue function and state its domain. The revenue function is that RQ is equal to the price times the quantity sold. So the quantity times the price we found out it was 3,000 minus 1/3 Q. So 3,000 Q minus 1/3 Q squared. Its domain would be the same as the domain of the cost function. Or the price function, sorry, the price function. Revenue function, now I want to find the revenue function. I mean the marginal revenue. The marginal revenue is R prime of Q, the derivative of Q. So that would be 3,000 minus 2/3 times Q, and again, dollars per TV. Now I want you to find R prime of 3,000 and R prime of 6,000 and interpret these values. So R prime of 3,000 is equal to 3,000 minus 2/3 times 3,000 is equal to 1,000 per TV. And R prime of 6,000 is equal to 3,000 minus 2/3 times 6,000 is equal to minus 1,000 per TV. So the interpretation is that if you sell 3,000, your revenue will be increasing since the derivative is positive. But if you sell 6,000, your revenue will be decreasing because you have a negative. Now we want to graph the cost function and the revenue function on the same coordinate system for 0 less than Q less than 9,000. And then we want to find the break-even point and indicate the regions of loss and profit. So the graph of the revenue is the upside down parabola. The cost function is the increasing linear function. The break-even point is around 55 TVs. And 84,079 TVs. The profit is between 55 and 8,479 TVs. So that's where you're going to have a profit, and your loss is going to be between 0 and 55 and between 8,479 and 9,000 TVs. Now find the profit function in terms of Q. The profit function is R of Q is equal to, P of Q is profit. P of Q is equal to R of Q minus C of Q. So R of Q was 3,000 Q minus 1/3 Q squared minus C of Q is 15,000 minus 150 Q. So your P of Q is going to equal minus 1/3 Q squared plus 2,850 Q minus 150,000. I keep saying that wrong, 150,000. Now find the marginal profit. The marginal profit is the derivative of P with respect to Q. So that'll be minus 2/3 Q plus 2,850. Then find the P prime of 1,500 and P prime of 4,500. So P prime of 1,500 is going to equal minus 2/3 times 1,500 plus 2,850 is equal to $1,850 per TV. P prime of 4,500 is going to equal minus 2/3 4,500 plus 2,850 is equal to minus $150 per TV. So the interpretation of these two values is if you make around 1,500 TVs or make and sell around 1,500 TVs, your profit will be increasing because this profit derivative is positive. So my profit will be increasing. If I'm making 4,500 TVs, making and selling 4,500 TVs, then my profit will be decreasing because the derivative is negative. It still will be positive because we're in the profit section, but you will now be making less profit for each one you sell.